Okay, so this lesson is solving rational equations. I'm not going to do inequalities. As a matter of fact, I didn't think they were. Maybe it's, I don't know. Anyway, we're doing activity or lesson 30-1, which is just solving equations. Okay, so we have this example down here. The bottom line is we have a fraction right here, and we want to get rid of the denominator. That's the main thing you want to think of. How do we get rid of the denominator? Well, this denominator is just a division problem. We've got this thing right here being divided by x plus 1. So how do you get rid of dividing by x plus 1? Well, of course, you multiply both sides by x plus 1. So all they've done right here is taken whatever the denominator is, and we only have that one denominator to worry about, multiply both sides of the equation by x plus 1. Well, over here, those cancel out. And I think I can write on this if I go do this. Okay, so over here, the x plus 1s cancel out. And that's why all you have left is this x squared minus 1. Over here, they did FOIL. Okay, so now you have a quadratic, or what looks like a quadratic. You've got to get everything on one side of the equation. So if you subtract x squared from both sides, oh, look what happens. The x squares cancel out. So now you have just a simple algebra 1 equation. Subtract 5 from both sides, divide by 6, and you get x equals -1. Okay. I'm going to run over here and do a similar example. I just made this up, so the answer may come out to be nice, and then again, it may not. So I have x squared plus 6 over x minus 2 equal to x plus 4. Okay, so I have a denominator. I want to get rid of the denominator. So what do? I multiply both sides by x minus 2. Okay. Understand that we need to put that in parentheses because we're going to do FOIL. This x minus 2 and that x minus 2 cancel out. So I'm left with x squared plus 6 equals, I'm going to do FOIL, x squared minus 2x plus 4x. I'm sorry, I said the wrong thing. Minus 2x plus 4x. And then that is minus 8. Okay, I'm going to recognize that when I subtract x squared from both sides, they're going to add to 0. So what looked like it was going to be a quadratic ended up not being a quadratic. I'm going to put these two together. Why? Because they're like terms, and I can. A negative 2x and a positive 4x becomes a positive 2x. Simple algebra problem. All I got to do now is solve it. What is that? 14 equal 2x. I can't believe I ended up getting a nice number. X is equal, oops, look at me doing crazy stuff. Divide both sides by 2, x is equal to 7. You do need to check and make sure, though, because why do we have to check and make sure we don't have extraneous solutions? Because at the original problem, we had a denominator. That means we had a restriction in our domain. The denominator can't equal 0. If you're talking about graphically, that means we have a vertical asymptote. But anyway, take the denominator, set it equal to 0. X can't equal 2. Okay, so we did not get 2 as an answer, so that means this answer checks. You can go back to the original problem and plug it in, though, and see that it does equal. Okay, so another example. Let's go back to the one in the book real quick. So another example is, we have a subtraction problem. Well, yes, but you can handle this in a couple of ways. I'm gonna go through this one, and then I probably am gonna work it a different way. Okay. All they did was they said, okay, look, we have a denominator, two denominators right here of an x, and we have another denominator of x plus 2. So just multiply both sides by x and x plus 2, and things will cancel out. Is that what's happening? Let's see. I don't know what I just did. Oh, poo. I have no idea what I just did. Okay, that's what I wanted to do. Okay, so what's happening right here? right here, this x is canceling out with that, and this x plus 2 is canceling out with that, and this x is canceling out with that. So all we have left over here, but see, this is where it gets confusing. Okay, so let me back that up because that's not exactly true. What we really have right here is a distributive property. Okay, we've got to multiply this x times this 2x, and then we've got to multiply x plus 2 times 2. Well, when we multiply the x times the 2 over x, it cancels out, but we still have to multiply these two together. Okay, and over here, when we multiply this fraction times this right here, the x plus 2's cancel out, but I still have to multiply that x times that. So that's where they got this right here. It really should be this, x times x plus 2 times 2 over x minus x times x plus 2 times 1 over x plus 2 equals 3 over x times x plus 2. So that right there had to be multiplied by both of them. So this x would cancel out with that. This would cancel out with that. And so we still have this 2 to distribute and this -1 to distribute. Okay, so that's where they got all this. Again, like I said, I could think of a different way to work this. Distribute those, combine your like terms. Then you have an x on one side. They subtracted 3x from both sides. And they also subtracted 4. They did 2 steps in one. That's where they got the -2x and then divided both sides by 2. Okay. Here's what I would have done if I were working this problem. I would have done it a little bit differently. I would have, not that their way didn't work, it worked just fine. I would have had 2 over x minus 1 over x plus 2 equals 3 over x. Okay, well, if you'll notice that this denominator and this denominator are the same, then they're really simple to combine. Notice I did not lose that minus sign. I just moved it up to the top with the -1. And then since the denominators are the same, all I got to do is subtract the numerators. 3 minus 2 leaves me 1. Now this is a super simple cross multiply problem. All we got to do is cross multiply. So x times -1 is -x. X plus 2 gives me that. Subtract x from both sides. -2x equals 2. Divide by 2, divide by 2. Oh, divide by -2. X equals -1. And of course, you'd need to go back and check the restrictions at the very beginning. X can't be 0, and x can't be -2. We did not get either one of those right there. So that problem is okay. So that answer is okay. So x is equal to -1. Notice I got the exact same answer that they did. They got x equals -1. Okay, it's just that I got it a little bit differently. Why? Because I noticed that these two numbers could be put together really simple. Okay, again, it doesn't matter how you do it. You just need to be able to do it. Okay, you could also, since this is a subtraction problem, get a common denominator and make this be one fraction, and then it would also just be a cross multiply problem. So like this problem right here is one you're going to have to do. Just multiply 5 times this, the numerator, and multiply x plus 5 times that numerator, and you'll get rid of all your fractions. Okay, it's not as magical as it sounds. Let me go back and show you that really at this step right here, -1 over x plus 2 is equal to 1 over x. I'm out of time. Notice what's going to make this side go away, multiplying by x. So I have to multiply this side by x. What's going to make this denominator go away, multiplying by x plus 2. So I got to multiply this side by x plus 2. Those cancel out. Those cancel out. So I just end up multiplying, just like I did the cross multiply. So it's just a little bit of a shortcut.